Well, these are the sensor PCBs for the keys. Keys push down on these rubber contacts. There's two contacts. One is to register the key press, and the other one is to register the velocity. If you hit a key hard, the two contacts will connect very soon after each other, so the keyboard knows you've hit the key hard. If you hit it softly, you may not even connect the second one, or it may take a longer time to do it, but that's how it detects the velocity. Looking on the board, I was expecting to find some rotten traces, and I did find some fairly rotten looking traces, as you can probably see there. But that is just oxide under the lacquer, which is fairly common in electronics of this age. What I thought was a broken trace, where you can see that little area of brightness in there, was the lacquer literally flaking off. So I thought I had found a broken trace, but it actually is perfectly good. I can't find any broken traces, to be honest. There's some that look pretty messy, but as there are two boards which daisy chain together, the fault could be on the second one. So this is the second board, which I've just started to clean down this end. There's a lot of muck on this. I don't think it's as bad as the other one, but pretty unpleasant looking. In terms of which keys were affected, it's kind of hard to figure out when it's in this state, but each key is has the 4 pads. So the D, which constantly sounded as velocity high, was 1, 2, 3, 4, 5, 6, 7 on those pads there, and the bad C before it was there. Actually, that's probably not correct. I'm not counting the black keys, so I'll have to recalculate which is where. But in the absence of finding any broken traces, I really am limited only to checking that the keys that are affected have no problems with the contacts, and then possibly writing it off as just bad, dirty contacts, which I can clean. It's a bit of a mammoth job to get this keyboard back together again, so I have to try and think of a way to test it before I do that. Or perhaps just build up put it together minimally, connect it up, and just actuate these with my fingers, just to see if we have got connectivity there again. But I will keep going with the cleaning and the searching. Yeah, I think this keyboard has had some stuff spilt in it at some stage. It might be cigarette smoke, actually. It's kind of sticky all over. The keyboard does have a kind of musty smell about it, but I reckon it's been in someone's shed for the best part of a decade, if not longer, judging by the amount of wildlife in it. Yeah, so I'll get back to cleaning, and I'll be back soon. Okay, well, I've done the cleaning on the PCB, and everything is looking very nice. This, you wouldn't really suspect this looked as bad as it did before. In fact, it looks pretty much mint condition. I took this chip off to clean underneath it because it was pretty well coated, and same with the 7400 down here, or the 4000. That had some residue well wedged underneath. So, it's clear the residue hasn't actually done the board any damage, unless it happened very recently, which I doubt. But I thought I might as well get it all off. The battery will remain unpopulated for the time being. If I do fit another battery, I will actually run a couple of wires to a battery holder elsewhere in the case. There's plenty of room in this synth for mounting the battery well away from the board, which is pretty much irreplaceable. So that's what I'll be doing, but in the short term, no real need to do that. The battery is absolutely stone dead, so it wasn't bothered by not having a battery for quite a while. I also took a read of the EEPROM, just backup, I suppose. Also quite like flicking through, seeing if there's any text in there. Sometimes they leave little comments. I've seen it on arcade boards before, little notes in the code. And this this chip did turn out to be just a standard 6116 static RAM, even though it's known as a 5517. I just ran that through my tester just to confirm it was okay, but as I said before, if there was anything majorly wrong with this board, the synth wouldn't have worked at all. So yeah, I went over the rest of the board with a paintbrush, just a dry paintbrush. In fact, I didn't actually dunk this in the sink. I held it up against the table with some kitchen towel underneath it and ran PCB cleaning solvent over the board and attacked that with a brush, and that is all it really needed, and that stuff evaporates very cleanly. Doesn't leave anything conductive trapped under chips like soap and water would have done. So that is now ready to go back into the case. I'm going to leave cleaning the case and vacuuming out all the crap until last, because I'm still hoping I'll find bits of those keys that have somewhat damaged. But what I'll do is I'll put this back in the case now. I've gone as far as I can with cleaning this, so yep, all good. Well, the PCB is back in the case. The good thing is, with all the wires tied up as they are, that everything just dropped into place. There was no problem working out which connection went where, which is exactly why I left everything as untouched on the top. It's basically using the memory of the wire, how it's been bent for the last 20 years to it tells you where it used to be. It's a pretty handy trick. In terms of the keyboard, we're down to the base skeleton, which I've just been out in the garden with the paintbrush, getting all the dust and crap and dead things out of. It's a pretty laborious process, but this really is the only way to clean a keyboard. There's just so many places for dust and crap and dirt to get stuck that giving the keys a quick go over with a cloth is not going to get anything more than 10% of the dirt. So I haven't been able to find anything wrong with these by eye or by buzzing through anything that looks suspect with the multimeter. So I'm going to build this back up without the keys and go along the board and actuate the pressure sensors by hand. The other potential culprit was this interconnect ribbon here, which there was a bit of a weak point in electronics. They tend to use these because they're cheap. It's just a ribbon cable to interconnect. If there was a break in one of these tracks, that would explain it. But I'll be able to test that once I get it back together. I thought most likely would have been the trace on the board, but it could be this. These give problems in a lot of 80s computers because the keyboard membranes are much the same, and these just fracture. One of the traces fracture inside. Now I could test this with a multimeter now, but to do that would mean bending it flat, which actually hugely increases the risk of me breaking one of the wires in here that was fine beforehand, so it's not actually a good test. So what I'll do is I'll plug it all back together, insert this back in, and then check whether I've got continuity between all the tracks on each board, because you can see each board has 2, 4, 6, 8 or 9 pads there, which connects down to 8 or 9 at the other end, and to the actual cables that go off to the main board. So I've buzzed them all through from end to end on both of the keyboard PCBs, and that proves that there's no breaks in the horizontal. Obviously, to the vertical they're all broken because the keys aren't there, and it's the keys that make the connections between the horizontal and the vertical connections on the matrix. So what I'll do, I'll put it back together and a bit of a dry test. Okay, the keyboard is back in, partially assembled anyway. I've put a couple of the grip studs in just to hold the PCB to the base plate. It's probably about another 50 to go on when it's ready to be reinstated. I've only put the lower half on because this was a pretty painful exercise. I ended up finding you need to use a prodder tool like this. This is a desoldering iron cleaning tool, just to prod down through these little holes here to get the studs to engage in the PCB. But before, I was getting a lot of dead keys. I had about 3 in the lower half of the keyboard, and those 3 are now gone. So the issue was either dirt on the contacts, which was possible, or a loose connection somewhere, or a dirty connection that had gradually lost contact over time, which the disconnecting and reconnecting for putting this together cleared. So there was no broken trace on the keyboard PCB. Of course, it's possible there are some bad keys in the top section still, but I think that's pretty unlikely. I would put these all back together, except the rubber strips do need a wash. They're pretty grubby still, and I need to go over the contacts on the PCB one last time. This was really a check to see if I needed to go any further, well, with checking traces by eye and with multimeters, so it wasn't really prepped for reassembly. But this is pretty much proves that this keyboard is fixable. Without being able to fix the keyboard, it's kind of a bit of a pointless exercise. So that's the main fault, and it looks like we're underway on that one. So I will, I've got to pretty much pack up now, so I will come back to this later today, give the rubber sections a clean, give the PCB a clean, and I'll put all the rubber strips onto the baseboard. And then if we have all keys sounding, then that's pretty much it. I need to start washing the actual keys themselves, gluing the broken bits back together, and tracking down some double-sided tape so I can fit the rather cheap and nasty keyboard, or the key lock strips. But this is pretty happy with this.